Hello, my name is Jeff Offit. I'm professor in the computer science department at George Mason University, and I'm part of the CS for All team. I'm going to talk to you just a few minutes about how computational thinking is related to computer science and how it's different from computer science. So we've already gone over these definitions and these terms in the module that computational thinking is a way to solve problems. And we talked about the 5 broad thinking skills. And it's important to note that computational thinking gives us solutions that we may or may not implement on a computer. So that brings up the question, when do we use computational thinking? Well, a lot of places and a lot of situations. And the rule of thumb I use is really to focus on that 5th broad thinking skill, which is if we're using a process in our solution as part of our solution, that's probably meant we incorporated computational thinking one way or the other. So here's some examples. One of the first example we often share with students in introductory classes is shampoo, because we've all read the instructions on the shampoo label that says lather, rinse, repeat. And then later on, we get to make a joke about looping and point out that there's some kid that's still in his shower who's been lather, rinse, and repeating for days and days and days. But that's a process, right? So when we apply that, we're applying computational thinking. When I learned to cut my grass as a boy, I spent some time thinking about, do I go back and forth? Do I go in a square? Do I make circles? How do I navigate around obstacles in the grass, like the swing set that my little sisters used? That's all computational thinking. And whenever we come up with, think about the process and how to follow a process to, reduce the amount of time we spend or to make our solution better, we're applying computational thinking. When we're cleaning, when we're searching for things, and searching, it doesn't matter if you're searching on the web or if you're trying to find something in your town or if you've lost something in your house. We come up with a process. And if you've ever seen a 3-year-old look for a lost toy, the process the 3-year-old uses is usually very inefficient. They often skip places where maybe they don't think it's likely the toy would be, and they go back to the same place, maybe the most likely places, over and over. And they often don't find the toy when an adult can find it very quickly. And then that's when we, as parents or adults, start to show that child how to apply computational thinking. And if you're a parent, or if you've ever helped a child try to find a toy, then you've taught computational thinking, and you may not have realized what you were doing, but that process of how do I search is computational thinking. So these are all examples, and there are many others, but I do think that key is, was there a process? So the last slide here is how are computational thinking and computer science related? And you've probably heard about computer science a lot more than computational thinking. That was our first module. Those are the standards of learning that are being applied in Virginia. But they're related in that computational thinking is the substrate, the foundation. That's the beginning point. And it turns out that computer scientists or programmers in general, they're using computational thinking to design programs that we then code onto a computer. Other uses of computational thinking may not involve a computer, but computer scientists usually do. And it's important. We have to learn computational thinking before we can learn to program or code. And we've seen that as a college educator. I've seen that in our programming courses, that students who come in and they don't really know how to think computationally, they struggle to learn to program or write code. And they think that computer science is really, really hard. Whereas students who come in and they're already good at computational thinking, they take that first class and they usually don't find it's that hard.